Okay, so we're on problem 155, and the reason that I wanted to go over this problem in particular is because it's really hard to know when you're only given pieces of information and you have to draw a graph or you have to write an equation, and it's always difficult to figure out like what information you need and in what order. Do you start with the first thing they tell you? Do you start with the third thing they tell you, or whatever? So I'm just going to kind of walk you through my thought process, and my thought process is not the only thought process out there. There's plenty of ways to do any math problem, but maybe this will help those of you who kind of don't know where to start. Okay, so first thing you should always do is read the problem, but actually read it all the way through. Don't just start reading and writing at the same time. Read it through once, and then you can start thinking about how to actually solve it. So after Theo used the motion detector, he used his distance time graph to determine the following properties of his motion. However, he lost a copy of his graph. Help him recreate a possible graph of his motion. So his average velocity was 0.5 feet per second. He turned around twice. He started while standing 3 feet from the motion detector and began to walk away from it at time t equals 0, and he walked a total of 9 feet during the 10-second interval. Okay, so I'm going to break down what each piece tells you about a distance versus time graph. So average velocity is total distance divided by total time, and that was 0.5 or 1/2 feet per second. So one thing I know is that when I draw this, I can use an average velocity line to help me figure out where the beginning and ending points are. Because when you are on a distance versus time graph, which I'm going to just draw a quick example of over here. If this is position versus time, and you have like whatever, some graph like that. The average velocity when you are graphing it over the interval is the same thing as connecting the beginning and ending points. And that gives you the average velocity, or the average slope, if you will, of your graph. So I know that my average slope, graphically speaking, can be found using the beginning and ending points connected with the line. It says he turns around twice, so I know that with a distance versus time graph, that means if he walks away and then walks back, that's turning around once, and then walks away again, that's turning around twice. So I know it's going to look something like that, because in part 3 it says he begins to walk away. So he's not walking towards the motion detector, he's walking away. So he's walking away, coming back, and then walking away again, and that would be turning around twice. And then it says he started while standing 3 feet from the motion detector, so I have a starting point. At time t equals 0. So that's going to be my y-intercept. And he walked a total of 9 feet. Now that's the difficult piece of information, because that is not a displacement. That is not that he ended 9 feet away. It's he was walking a total of 9 feet, which means when he's walking away, that could be like 3 feet, and then walking back, that could be like 2 feet, and then walking away again, that would be 4 feet. So walking away, towards, and away again has to be a total of 9 feet. So we're going to have to figure out some way to kind of piece that together. And it might take some guessing and checking. You might not be able to figure it out right away, and that's okay. Okay, and it says during the 10-second interval, so we know it's going to take 10 seconds. So I'm going to start my graph. It's a total of 9 feet, including walking towards and away, so I probably don't need more than 10 dashes for my feet. So I'm going to go up by 1 foot, 2 foot, 3 foot, 4 foot, 5 foot, 6 foot, 7, 8, 9, 10. Ooh, perfect. And it's a 10-second interval, so I'm going to go ahead and go from 0 to 10 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, so close. Okay, so this is time in seconds. I apologize for my terrible handwriting. And this is position. Try not to say distance. It's so vague when you say distance. Does that mean distance away from a starting point? Does that mean total distance? So I always like to say position. And that is in feet. And it is important to label your units so that you don't get confused and your grader doesn't get confused. Wow, this video is already 5 minutes long. Okay, so he started while standing 3 feet away. So if I'm given a starting point, then I'm going to use my starting point. That's right here. He begins to walk away from it, He turns around twice, so I know that means we're going to have we're going to have a max and a min. And then his average velocity was 0.5 feet per second. So again, I'm kind of just reading through the information, seeing what I can use next. I started with 3 feet, so I've got that in there. His average velocity, I said that was going to be a line that connects beginning and end. So I'm going to go ahead and figure out what that looks like. That is going to be a slope of a half. So up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. So I can actually find an ending point because I know that the end has to connect to the beginning with this line. Now, I'm not going to use a solid line. That would be silly because a solid line means that it's actually part of your graph. This isn't really part of my graph. It's just a helping hand. So I'm going to dash it. Okay. He starts walking away. So what I'm going to do is I am going to kind of just start sketching it out and then seeing what happens and seeing if it matches my information. So he walks away. Let's say he goes 3 feet away and ends at 6 feet away, and then kind of turns around and goes back. Let's say he goes back like 2 feet and then goes away again. So something, oh, I went a little bit past 10. Let's go back. There we go, something like that. Okay, now let's see if that matches my information. So this, from 3 to 6 feet, that's adding 3 feet. Then I'm going back 2 feet, but it says the total distance is 9 feet, so I'm just going to consider that a plus 2. And then he walks away, and we went from a distance of 4, because this is the 0.54, and 4 to ending at, this is 3, 4, 5, 6, 7, 8. This is 8 feet. Okay, so let's see if that makes sense. So we're going 3, then backwards 2, and then another 1, 2, 3, 4 feet. So does that add up to a total of 9? Yes, it does. Okay, now that was a guess, and I was very lucky, and I guessed correctly to go forward 3, backwards 2, and then up 4. But that was kind of luck. And your graph doesn't have to look like this. It could be something, I'll show you another example. If I was going forward 3, but that was like way over here, like something like this, and then backwards 2, and then up 4, it could be something like that. And that would be the same thing. You're going up 3, then down 2, and then up 4, and that still adds up to be 9. And again, it's okay if you have to guess and check. So let's say that I tried something else. Let's say I went forward 4 and then like down 4 and then up 5 or something like that. And then I were to add it up and it's not 9, so I erase it and I start over again. And that is totally fine when you're doing these problems. So you can expect to do a little bit of guess and check when you are doing problems like these. And these problems, when I'm going over them, because I'm talking them out, it takes me about 3 or 4 times as long as it should take you to really piece this together. So I know this video is 9 minutes long, but it should not really take 9 minutes necessarily to do one of these problems. And I would say this is a good test problem. So I would practice problems like these. So that is that, and I hope this was helpful, and that I have no sign off. So goodbye.